everybody. Going live, we'll do it live. Profit of our time. Anyways, just setting up the Facebook Live right here because we're making this happen. We're live from the spaceship right now. So, I'm bad at multitasking. I'm really bad at multitasking, but I want to make sure everybody can do this. We're going to talk about relativity today. We're going to talk about who knows what. It's going to be fun. So feel free to comment with any questions. We'll get into this in 1 second. Let me get Facebook on here. Space Jam. I'll call it Space Jam. I think that works. All right. Starting live video on Facebook. That's what we're going to call it, Spacebook. And got to come up with a spacey name for YouTube. We'll figure that out. Anyways, I'm your host, Josh Urban. We're going to do an experiment with general relativity today. We're going to talk about that. We're going to talk about black holes. I have the fabric of space-time right here. This is my DJ tablecloth, actually, but it's going to double as our fabric of space-time today. We're in orbit today around the moon. You see gravity is kind of weird. There's a lot of red tape in the air nowadays with all the pandemic stuff. And got the trusty friends right here. Got some scopes. And what's up, Tara? How you doing? Good evening. So I was talking with my folks today about general relativity. And they gave me family is good because we kind of like heckle each other. So I think I'm ready to talk about this. I'm not sure. We'll talk about this. So Einstein was working in a patent office when apparently he had what he called the happiest thought of his life. It was about a man falling off a building. And you might be like, well, sicko, man, what a sicko. Well, hey, all geniuses are a little out there, right? But he thought, well, if a man falls off a building, he's going to feel weightless. This was the happiest thought of his life. Backing up a little bit, I could be wrong about the timeline of this history, but apparently Isaac Newton was sent home from school because they had the plague back in 16, whatever. So did he sit around and watch Netflix and run out of things to watch on Netflix? Did he sit around and just eat pretzels and goldfish? No, he invented calculus and the Newtonian reflector. This is a Newtonian reflector right here. And I think he came up with the gravity thing. It might have been after that. I'm not sure. Just fair warning to everybody, in an effort to be entertaining, I've had a massive amount of coffee, which is like 2 little cups for me. So I really am in orbit around the moon right now. So before I forget, if anybody has any questions, it's almost an Ask Me Anything. I reserve the right to decline a question. But if you have any space questions or any discussion, feel free to leave it in the comments right there. Just comment at me and we'll chat about it and get a shout out on the air. So Newton, the story goes, he saw an apple fall, right? Saw the apple fall. Look at it just floating in the air right there. Saw an apple fall. And he wondered, well, why did it do that? So he came up with the Newtonian laws of gravity, which, let's see, it is an object will attract, hey, what's up, Les? Will attract another object, or the attraction of a more massive object on a lesser massive object will be inversely proportional to the square of its distance. So basically, the closer you are to something, if you're this close to something, you'll feel it, say, X amount. And if you move farther away, you're going to feel it less. That's technical talk. So inversely proportional to the square of its distance. So the farther away it moves, much less it's felt. So this described a lot of things. What's up, Rob? How's it going? This described a lot of things, but it didn't really explain how it worked. My brother was joking around today. He goes, maybe, and he doesn't really think this, but he was joking. He said, maybe it's like little goblins and they're pulling on things, right? So what is the force of gravity? How did it figure it out? So I've got some props. Got some props to you guys. I know these are less than ideal circumstances, and we'd all probably rather be out, eating ice cream and walking around, but we wouldn't be having this conversation. So, it's kind of cool, right? Okay, so, and I know this is sort of me going and not really talking. It's not exactly a conversation, so feel free to comment. I'm doing this on YouTube and Facebook. So feel free to comment. And where'd the 9 ball go? If you have it, there it is. Got to get the sun. Hold on a moment. If you have any questions or observations or thoughts to add, would love to hear it. Okay, so Einstein came up with this theory that still stands today, although the wonderful thing about science is if you have a better idea, put it forward, and we'll try it out. Well, not me personally. I'll be like, oh, I don't get it, man. So now this is a rough approximation of how it works, but if you imagine space as an actual fabric, which is, pardon the star pun right here. And then we take something pretty, well, anything will warp it, but something really massive like, say, this would represent the sun. And as the sun sitting right there, see how it pulls the fabric down a little bit. So if something is traveling along, it will be pulled around by the sun. Picture a little marble coming in here. I don't have a marble with me. I don't think I own a marble, actually. I've lost them all. So we'll go around like so. So this would explain how gravity works. And it actually, this can be used to describe with the utmost accuracy of how it works. So came up with this idea, and he thought, well, okay, this is a rather novel idea, but how? And everybody was like, yeah, it's kind of weird, man. And then if you're hearing this for the first time, you'll be like, yeah, that's kind of strange. So how do you prove something like that? And we're gonna see it. What's up, Drew? We're gonna see it in a moment. We're gonna go well outside the spaceship. We're gonna return back to Earth and demonstrate it. But for now, a quick story. So he figured out. He said, well, what is the most massive thing around near, relatively close at hand? He said, well, the sun. Okay, so he had a really clever idea. He thought, okay, if you took a picture of the stars, let's say the stars are here. Now the stars are moving around, right? But from our perspective, they might as well be fixed for experimental purposes. So the stars are here, and the sun comes in near the stars, right, like this, and the light from the stars is coming. We should actually be able to see something that's theoretically behind the sun, and it would. If the photon's like a little marble, it's going to come into the well and zip right around it. It's going to be traveling in what it thinks is a straight path, but since the whole path is curved anyway, it's going to appear to curve from our perspective. But the problem is you can't really see stars in the daytime, right? So they waited for an eclipse. Now the idea was that if the moon goes in front of the sun, it will block the rays of the sun, and then you can see the stars around it. And then you can do my lips don't match my words. Oh, is it out of sync? Don't know how to fix that. Maybe we could dub it in Japanese. Maybe that would fix it. Yeah, it's probably, I have this lousy little phone I got at Walmart. It's probably what's going on. I could just go like this. Maybe that would be easier if my sound and my audio is out of sync. What's up, Richard and Robin? So, talking about general relativity. Okay, so the idea is that if the sun is warping space, the stars will look different when the sun's near them than when it's not. So, during the solar eclipse, the moon blocks out the sun, we can see the background stars. So, he worked out these equations. He thought they were right. World War I was happening, sent a research team into the path of the eclipse, which happened to be in a war zone. And then cool, glad to hear it, Rob. And glad to hear it, Tara. So send the eclipse into the war zone. They were captured, they were thrown in jail, and they weren't able to do their experiment, which is just as well because his numbers were wrong. So we worked on them a little bit more, and then eclipse of, I should know this, 1919, I want to say, could be wrong on that. Sent the expedition out. So they had a picture where the stars were supposed to be. The solar eclipse happens. You take a picture where the stars appear to be, and if space was warped, the photon would be zipping around as well in space instead of flat space. And sure enough, the plates, the photographic plates, the stars appear to be in different places, proving that this was one way to describe how space works. Now, the cool thing is with science is like, maybe it doesn't work like that, we'll figure it out. As of now, this is how we think it works. Kind of cool, right? So again, flat space, something massive comes along, the more, anything will warp space, but the more massive it is, the more it'll pull it down. A black hole will be down here. We'll talk about that in a bit. Okay, so, and if anybody has any questions, feel free to comment. Okay, so we have this. So now the question is, what was the happiest thought of his life he was figuring out? So he thought, well, if a man is falling off a building, because he hadn't come up with this theory of curved space-time yet, or that space and time were related. So he said, okay, well, if a man is falling off of a building, he's not going to feel anything. He's going to feel weightless. This is the sort of the idea. If you're in an elevator and you're in a really tall building, well, let's say they blindfold you and they put you in an elevator and you don't know where you are. You could be in the International Space Station. You could be in a really tall building. And you find yourself weightless. You have no way of knowing if the elevator is in a free fall or if you're in deep space and you're just floating. This is called the equivalence principle. In other words, gravity is not necessarily a string that's pulling on anything. It's the object is following the straightest path through space. So what we're going to do next is take this bottle of water outside. I've got a step ladder set up. We can see this for a fact. So I'm going to poke a hole in the bottle of water. And what's going to happen is the water's going to come out. I'm going to take the cap off so there's not a vacuum. So the water's going to come out. And then I'm going to drop the bottle. So the water and the bottle are following the curved path of space-time. The water is going to stop coming out of the bottle until it hits the ground. And that's going to come out again. Uh-oh. Sorry, everybody. My phone tried to update right then. That's annoying. Okay, so I'm going to move everything outside. I got a laptop for YouTube Live and this, and we're going to try this experiment. And one of the things that's hard to visualize about this is obviously this is a two-dimensional way to represent a three-dimensional thing. The whole matter or whole existence itself is actually warped. So just keep that in mind. It's an experimental limit, or it's more of a function of our brains not being able to wrap our heads around it and not really how reality is. I saw this great quote that said, the universe is under no obligation to make sense, which is pretty cool. I like that. Okay, so move everything outside. I got a laptop and a phone, so we got it. You can see the secret that it's actually not a spaceship, not in orbit. Well, actually, I am in orbit around the sun. Okay. Let's put everything out here. Okay, so I have a ladder. Water. Two of them. Okay. Put that right there. You can see that? Okay. I'm going to go up here. Actually, let's arrange this so I can get more of the angle. More of the drum. Okay, watch for the water to stop coming out of the bottle. Open this up. Come on. Okay. Did you see it stop? I need a taller ladder. Try it again. See that? Did you see that? Did you see that? Did you see that? Stopped. The water stopped coming out of the bottle. What? So that means it was following. Oh, well, okay. The beetle and the branch. I didn't tell you about that. Okay, so I was watching this video, and I'm still trying to wrap my head around this, and still trying to explain it in a way that makes sense. But what we have is this video I was watching said when I didn't know Einstein had kids, but when his son was about 12, he said, "Dad, why are you so famous? What did you discover? What is this thing?" And Einstein thought, and really a testament to how smart this guy was. I mean, obviously he's smart, but like a lot of times smart people can't explain things. So he said, well, picture a blind beetle is crawling along a branch, a curved branch. Thank you, Les. Just get so excited about this. So picture a blind beetle is crawling along a branch, curved branch. And as he crawls along, he's not going to know if it's curved or not. He's just taking the most logical straight path that he could, right? So the branch would represent how space-time itself is warped and curved by these gravitational distortions. And we're just following that branch. We can't really tell. We can't really see what it's curved in relation to. It just, everything is warped. Kind of seems like life, right? Everything is warped. So anyways, anybody we have any questions, comments? I don't know that as well. Sit here, take a deep breath. And by the way, those bottles of water that was recycled, that was not actual bottles of water that everybody's buying for $50 on eBay right now. No bottles of water were harmed in the making of that gravitational demonstration. All right, so now moving on. Everybody been noticing how cloudy it is lately? Well, it's nice to be here in space, right? Finally got a chance to see some stars last night, but then the clouds rolled in again. However, if you are blessed with clear skies, a couple of things to check out in the evening. Oh, Tara says, can you show the bottle drop in slow-mo? Well, I guess technically I could. I don't know how to do that with my phone. However, where I got this idea from is the physicist Brian Greene goes on the Colbert Show. So I'll post a YouTube link of that later, and he has he's on the second story of the set, and he has a lot of water coming out of it, and you see the water stop. So I'll post that later because that you can really see it there. It's really cool. I was standing on the ladder a couple nights ago, just kept dropping the bottle, going, "Whoa, I see it! It's awesome." So yeah. So if the sky's clear tonight, if you look out in the west towards the sunset, it looks like a UFO. Absolutely. It looks like a UFO. You'll see that's Venus. So really cool. If you look at it through binoculars or telescope, you'll see it's actually in a half moon phase. So that's super cool to check out. And then shout out to Bob. He just sent me a text a little while ago that says in the morning sky now, the planets are looking really nice. It should be Jupiter, Saturn, and Mars that you can see. So if you want to get in on some of the space action and you don't have any optical gear, you don't need any optical gear to see that. Just go out and look at it. Got to get up early though. So that's what's going on there. And oh yeah, let's talk about black holes real quick, and then I probably should go do some deep breathing or something. Okay, so fabric of space-time again. I was just talking to a couple of buddies about this, and my folks doing a virtual lecture the other day, talking about, are we holograms? Are you a hologram? Maybe, quite possibly. Okay, so let us visualize the black hole again. Okay, so you have the sun pulling down the fabric of space-time. Sorry, YouTube. I'll do this right here. Sun pulling down the fabric of space-time right there. Little telescope right here. We're pulling down the fabric of space-time. If you have something more massive than the sun, a big star, it'll blow up and then collapse in on itself and make a black hole, right? Like this, except it's in 3 dimensions. So you could also think of it as an infinitely small point that sucks everything in around it, like a dead star pulling things in. Different way to think about it. Okay, so something comes in, something comes up. There's a line around it where no light can escape. Not even light can escape from it. That's why it's called a black hole, and that's called the event horizon. It's roughly illustrated with this. The idea is if something falls into the black hole and doesn't come out, it effectively gets destroyed. And so they say, there's a law of physics called the information paradox, which says, if I were to destroy this billiard ball and hit it with a hammer, if I had a detector, I could capture all the energies and all the materials, and even if I melted this down and completely burned it, it would still be evidence of what it was, and I could sort of reconstruct it at one point. But if it goes into a black hole, all of it gets squished beyond recognition. So it destroys information. And apparently the laws of physics are stipulated on the fact that you can't destroy information because you will delete the universe. Oops. Are you sure you want to complete this action? Cannot be undone, right? So, but possibly, and this is a really exciting thing to think about, possibly the information isn't erased when it goes in the black hole. As it goes in there, the more it eats, that's so one way to think of it. So the bigger it gets, if something falls into the black hole, which you can picture almost as the event horizon would be like a sphere that which things can't return from. As it grows, is a 3-dimensional object falling into it somehow imprinted on the 2-dimensional surface? Maybe. And if it is, then in a way it could be considered to be a hologram. Some people say, some physicists say, think that the edge of the universe is 2-dimensional and we're holograms. Think of the thing on the back of your credit card, right? The little eagle flying. So possibly everything is a hologram. Huh. We're worried about the virus, right? Weird stuff. Weird stuff. I'm still working on understanding that, so we'll get into that later. But if you have any thoughts, let me know. If you know about this, let me know. Have you all ever also heard that theory? I think Elon Musk subscribed to this that says we're but video game characters of an advanced civilization, got bored. Maybe they had a lockdown or something like that. And we're just characters in a video game. Now, I like to think not, but you never know. So anyway, folks, a couple of weird things from the spaceship from our Space Jam this evening. Hope you guys have got something to think about, something to chew on. Let me know if you see anything cool in the sky. We need to talk about aliens next. Just borrowed a book from my brother on aliens, so we'll be talking about that soon. I got to read that. And we'll see you around on Facebook. Thanks for watching. Be well.